Welcome to Math TV with Professor V. It's Wednesday, December 7th, 2022, and here's the integral of the day. We have another definite integral from 0 to natural log of rad 3 all over 4 of 4e to the 4x over 1 plus e to the 8x dx. We actually did this in my Calc 1 class on Monday, so if that's enough of a hint, since in Calc 1 the only integration technique you know is U-Substitution, that's going to be the one to utilize. So if you can't quite see it just yet, I'm going to rewrite the integrand to perhaps inspire you. So 4e to the 4x, let's leave that alone, dx over, and then in the denominator, I'm going to rewrite e to the 8x as e to the 4x quantity squared. Yes? Okay, so pause the video if you need to marinate for a minute, give it a try, and then let's hop to it. U sub time. We're going to let u equal e to the 4x. And then du, be careful, we have to use the chain rule, so it would be 4e to the 4x dx. And since we have limits of integration, let's change those so that they are in terms of u as well. It's just best practice to do that. On some occasions, you know, I won't, but honestly, change those limits immediately like you would change a dirty diaper. Okay, so u of 0 is going to be e to the 4 times 0, e to the 0, which is 1. And then u of natural log of rad 3 over 4 is going to be e to the 4 times natural log rad 3 over 4. The 4's cancel. You just have e to the ln of rad 3, which is rad 3. Oh, beautiful. Okay, so now our new integral, all in terms of u, is going to go from 1 to rad 3. Look at this. I mean, we couldn't have asked for a more beautiful substitution. Bam, that's du over 1 plus, e to the 4x is u, so it's just 1 plus u squared down there. Bravissima. Okay, now look here. There isn't really much to do other than recall your derivatives. This one should be familiar. It's good old tan inverse, yes? Tan inverse of u, and we're evaluating it from 1 to rad 3. No, I don't need to back substitute and replace u with e to the 4x because my limits of integration are in terms of u also, so leave it as is. So we have tan inverse of rad 3 minus tan inverse of 1. Don't you dare even think about grabbing that calculator, no. When is tangent equal to radical 3? I just always think, oh, tangent of theta is sine theta over cosine theta. When does sine have a rad 3 in it? At what reference angle? At pi over 3. Minus tan inverse of 1. When are sine and cosine the same in magnitude and sine? Oh, at pi over 4. And then pi over 3 minus pi over 4, common denominator is 12. This is pi over 12. Isn't that cute and pleasant? It looks much uglier when you first take a look at it, but then it all comes together so nicely. It was written with great care. So I hope everyone has a fabulous Wednesday. We are starting to review for final exams in my classes, so I assume most of you out there are as well. So I'll link some of my playlists if you just want to let them run to brush up. And if there's any particular topics that you can't find for whatever reason, then become a member of this channel so you can make specific requests. You can also join my Patreon and have poll preferences on what sort of video topics you'd like to see. You can also see what I'm up to on Instagram and TikTok at Math TV with Professor V. Have a good old time. And I hope everyone has a great rest of your day. Talk to you guys soon. Bye.